Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will calculate the mean, median, and variance of a continuous random variable. So the formula for mean or expected value, variance, standard deviation, which is the square root of variance, and median are given here. This is for a general continuous random variable. There are special formula for uniform and triangular distributions. It's a lot easier to use these two formula than calculus, so I put them there. Please pause and copy down if you need. We'll now move on to using these formula to calculate mean, median, and variance for a general continuous random variable. So if a random variable has this PDF, and we saw this on a previous video, we're going to calculate its mean, variance, standard deviation, and median. So note all of these formula were on the previous slide. So let's start with the expected value. So you integrate from the lower limit to the upper limit of possible values, and it's x times the PDF, and don't forget to write the dx. So we're simplifying this function here. Of course, x divided by x to the power of 5 is x to the power of minus 4. So, of course, what we do, we'll keep the 64 as it is for now. We're going to increase the power of x by 1 and divide by the new power, and that will be between 2 and infinity. Of course, x to the power of minus 3, we can move that to the bottom of the fraction and write it with a positive power. So if I substitute x equals infinity, what I get is 64 over minus 3 times infinity. So remember, on a previous video, I said that was 0. Any number divided by infinity, a number divided by a really large number, gets closer and closer to 0. So that part's just 0. Now I substitute x equals 2 into here, and I get 64 over minus 3, 2 cubed is 8. So I actually get minus negative 8 over 3. The expected value is just 8 over 3. So you need to calculate the expected value in order to calculate the variance. So I'm going to get rid of these calculations. Please pause and copy down if you need. So to calculate the variance, what I'm going to do is integrate. I'm still integrating from the lower limit to the upper limit. So remember, the variance should be one number, so I need numbers here. So it is x minus the expected value squared, and then I multiply that by the probability density function. So in order to simplify this here, I'm going to expand these brackets. So after expanding these brackets, I'm going to multiply each term in the bracket by 64 over x to the power of 5. And so now I'm going to integrate term by term using the rule increase the power by 1, divide by the new power. So now we're going to substitute in infinity and 2. So remember I said when you're dividing a number by infinity, it just equals 0. So if I substitute infinity, here I get 0, here I get 0, here I get 0. If you divide a number like 1024, for example, by infinity, by a really large number, you get really close to 0. So it's just going to be 0 minus. Now I'm going to substitute in 2 into each of these. So this is what I got after substituting in 2, and that just gives me the number 8 over 9. The variance of this random variable with this probability density function is 8 over 9. So that means the standard deviation is just the square root of 8 over 9, which is about 0.94. So even though we just are using a formula to calculate the variance, just be careful. There's so many steps to make errors, and you have to expand the brackets first. X minus expected value squared, it's easiest to expand that and then multiply by the PDF. All right, I'm going to rub this out, so pause and copy down if you need, and finally we will calculate the median. So what are we actually doing when we calculate the median of a continuous random variable? So this PDF, its graph is shown here. Now, because it is a valid PDF, that means that the area under the curve is equal to 1. So what we do when we find the median is we're finding the point along here that cuts the area in half, so that this area is equal to a half and this area is equal to a half. What this formula is saying is the median is k, is the special number, so when you integrate from the lower level to k, the area under the curve is a half. That's what we're doing when we find the median. So to find the median, it's sort of like we know our answer already. We know the answer is going to be k. It will be the number k, so that when we integrate from 2 to k, I chose 2 because it's the lower limit of values x can take. When I integrate the PDF from 2 to k, I will get a half. So we just have to solve this equation here. So to integrate this, we use the same trick. We increase the power by 1 and divide by the new power. I end up getting minus 16 over x to the power of 4 between 2 and k must be equal to a half. So let's substitute in those numbers. So if I substitute x for k, I just get this. And if I substitute x for 2, I get minus 16 over 16, which is minus 1. So I just solve this equation. I have minus 16 on k to the power of 4. So these two minuses make a plus. Subtracting 1 from both sides, I get minus a half. So then k to the power of 4 is negative 16 divided by negative a half. I just move the 16 and the fraction line over. I get k to the power of 4 equals 32, and that means that k will be equal to the 4th root of 32. And putting that straight on our calculator, we get about 2.38. So 2.38 is the median because it is the point along this x-axis, so that the area before it is a half, the area after it is also a half. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.